I can explain that scatter plots can only be used to represent quantitative variables. I can identify the independent dependent variables and describe their relationship. I can construct a scatter plot with an appropriate scale.
Keep going, Hale. I can identify an outliers on the scatter plot. I can recognize that correlation does not imply causation, and that causation is not illustrated in the scatter plot. Keep going. I can choose two variables that could be correlated, even though neither variable could reasonably be considered. Reasonably be considered to be the cause of the other and defend my selection.
And then I can determine statements of causation that seem reasonable and unreasonable. So that's what we're going to kind of be going through today in your notes. Here are our scatter plots. Positive correlation is when x increases, as our y increases, our x increases. So as x is increasing, your y values are also increasing. And if you think about slopes, this is a positive slope, right, going up. In this one, we have our a negative correlation, like a negative slope. As the x values increase, our y values are decreasing. And in the last one, there is no correlation. For example, if I look at height and grades, there should not be a correlation. Meaning if you're shorter, you do worse, or taller, right? That shouldn't have a correlation, okay? So as we are looking at that one, no correlation means your points are going to be spread out and there's no relationship. So right now, on that next part down in your notes, please put positive, negative, or no correlation as you look at each of those. Positive, negative. Looking at Nevadas, and we're talking about their temperature in Celsius and elevation. Positive, negative, no. Negative should be negative. If we go down to that next one, Jacob, what do you have for shoe size and IQ? Should be no correlation. If we are looking at income and education, and my guess would be that this is income maybe per month if we are looking at that. What would we say that one?
Positive.
It's positive, but it's probably going to be, and at the end of this unit, we're going to be talking about if we have a weak or a strong correlation. This one would be a weak positive, but it still would be positive because it looks like overall as our education increases. And in this one, we definitely have an outlier, right? Looking at that income compared to the rest of them, okay? And if we are looking at this next one, we're looking at exam scores and the number of missed classes. So up to like about 25 classes missed, and then the scale, and this one would also be on negative correlation. Okay? On the next page, you are going to be graphing yours. So it says to make a scatter plot. So 3 questions in your homework today. I'll be giving you a graph paper. We'll be asking you to make a scatter plot. It says usually when you look at yours, x coordinate and your y coordinate. So if you're looking at plotting it, it is at 10, 2.5, right? So be sure to choose a good scale for your numbers so that they'll fit appropriately. So in this case, it looks like our dollars spent go from a low of 4 up to 13. And if I'm looking at the tick marks down here, this would be my dollars. So dollars spent. And it looks like we should be able to go with 1, 2, 3. So please put your numbers in going across.
I'll try to check out those.
Yep, and the video and the notes will be on them. Okay. If we are looking at our y coordinate, that's going to be our gallons that we bought of gas. And that's on our y, and it looks like it's going from 1.1 up to 3. So we might go up by a half, right? So if this is a half, we might put 1.0. This would be 2.0. This would be our 1.5, right? If you want to write each one in, you could. And we can't really answer this question down here describing the data until you plot your data. So now plot it. You're going to go to 10, 2.5. You're going to go to 11, 2.8. to go to 9, 2.3. 10 is at another 10 at 2.6, so right above that. So sometimes scatter plots are going to have a lot of points on a certain one, either on your X or your Y as you're going on that. So 13, we were at 1.3. No, 3.3. 13 was 3.3. 8 was at 2.2. 5 was at 1.3, right? And 4 was at 1.1. So it says as the dollars spent, as it looks like this, as the dollars spent increases, okay, so as the dollars spent increases, we would be looking at the number of gallons bought also what? Increase. This means we have a positive correlation. Okay, so we're talking about a positive correlation on that next page. And we're not drawing a line connecting them, it's just a scatter plot. Later this week when we look at trend lines, tomorrow and on Wednesday, that's when we'll start looking at that. So it says, if we are looking at these, you are asked to just put down, do you think it's positive, negative, or no correlation? So there will be probably 4 or 5 questions in your homework that look very similar to it. So looking at relationship, predict if you think they have positive, negative, or no correlation. If you were to graph it as a scatter plot. So if you think of it, sometimes it's helpful to just think, okay, what if I was going to plot the 2 variables on an axis? And should there be any relationship? So a lot of times you don't have to plot it, but it might give you, if you're struggling, if it should be positive or negative or no correlation. For example, the temperature outside and the number of people in McDonald's. If we are looking at the people, the temperature down here, and the number of people at McDonald's, right? Do we think there should be a relationship with the temperature? No, I mean, it should really be all over. So this one should be no correlation, right? If we're thinking about that. If you haven't had a chance right now, please go through the rest of them and think positive, negative, or no. Anna, what'd you have for the first one?
Positive.
Positive, I agree. As we get more hours of work, right, we should get higher pay. If we are looking at that next one, Piper, what are we looking at?
Negative.
Negative. So if you owed your parents money over time, that amount should go down to where you're getting closer to 0 for your dollars, right? And this would be like the weeks if you're thinking of it. And in that next one, if we are looking at that one, what would you say, Emily?
No correlation.
Should probably be no correlation. Like we talked about, Fargo has more population than Moorhead, but less letters. So as we are looking at that. And what it asks you to do now, it says make up one example, classify the type of correlation, be prepared to share your examples. So if you want to think of doing one that's positive, would be my hint, do one that's negative, a situation that you think, and one where you come up and there's no correlation. Okay? So think about each one of those and be ready in a few minutes. Use some different graphs that are really kind of interesting on this website that I'm going to show you in a few minutes, where we look more at the causation. So causation is when a change in one quantity is causes the change in a second. So a correlation between quantities does not always imply causation. So the following situation, is there likely to be a correlation? Well, you can answer that question. It says, if so, is it reflected as a causal, so causing relationship? So as we read this, the number of loaves of bread baked, and if we are looking at the amount of flour used, do you think that's positive, negative, or no correlation? Positive. And the question is, so you're going to be writing this down, so please write this in your notes. There is a positive correlation, and it is also causal, because using the flour causes us to make more bread, right? Each loaf of bread requires so much flour, so it is considered to be both a positive correlation, you're going to write that right in there, and it's going to be like there's causation. So some of you aren't writing. Start. This next part we are also going to write down. This next situation says the number of mailboxes and the number of firefighters in the city. And I want you to think about this. So mailboxes aren't just at houses, right? They're in apartments. And if you have more mailboxes, what does that probably mean? More houses, more people, right? But does that cause you to have more firefighters? Now, so here's when we look at this. We're going to say that it is a positive correlation, okay? So when we look at that, it is actually going to be a positive correlation because generally mailboxes increase when we have more people, and that would probably mean we have to have more firefighters, right? Okay, so positive correlation because both the number of mailboxes and the number of firefighters tend to increase as the population of the city increases. However, just because we put in more mailboxes does not cause the number of firefighters to increase. This is key. It does not, just by putting in more mailboxes, say the city go, oh, we better hire more firefighters, right? It doesn't cause it, but it might be because the population that they put it in. You can put up mailboxes without people, right, in apartments. Like some of these massive apartments going up all around town, they got a ton of mailboxes. If there's no one living in there yet, population has an increase to go with that, okay? So you want to write down the rest of that it is not causation, okay? So again, this will be on the daily planner, and it will be, I'll put the video up with it also as you are looking at this. So, that next page as you were looking, or that next part in your notes, they are asking us, as we take a look at this, is it likely to be a correlation between the cost of a family vacation and the size of their house? So, cost of family vacation and the size of their house. What do you think?
No.
So, correlation. You think if you have a bigger house, you might be going on vacation? So, maybe a correlation. Right? But does it cause it? And the reason they put here is that families spend more money on vacation. Probably they have enough money to have a bigger house. Do they have to have a big house? No. So as it says, is this, if the correlation, is it casual? If you're looking at it, does it cause it? And in this case, we would say no. Spending on vacation does not cause us to have a bigger house, right? So there might be a correlation in that if your family can go on more vacations, maybe you live in a bigger house, but that's not always the case, right? There's some people that choose to live in a smaller house because they spend all their money on vacations, right? Or doing other things, right? Or they save their money or whatever you're looking at, okay? So make sure you have both these two down in your notes for 1A and 1B. The next one says we're going to give two real-world examples of two quantities that are probably correlated but do not have a causal relationship. So one does not cause the other one. So I want you to think about different things, and hopefully maybe you came up with a couple. The number of bedrooms in your house and the number of people who live in your house. So just because there's more bedrooms does not necessarily mean you have a lot of people in your house. Because people could have moved out right now, or right? So it does not, one does not cause the other. For example, I think on Broadway, that lady that lives in the Hector Mansion, there are many bedrooms in that house, in that mansion on Broadway that we'll be walking by next week or later this week. She's one person living in there. There's lots of
one
bedrooms.
person?
Some of you might be in a big house where you have 4 or 5 bedrooms, and it might be you and your parents, right? Then there might be a house where there are just 6 or 7 people, and they have 4 or 5 bedrooms, right? So it all depends as you're looking at that. Here's another one, the amount of time you practice for a band concert, the number of mistakes you make when playing in that concert. Hopefully the more time you, and we would think that this one does, if you're looking at this, they do have a causal relationship. Hopefully, the more practice, you don't continue to make those same mistakes, okay? What I wanted to show you also is you're going to be doing on page 340, and we are going to take a quiz in a minute. So this is the page 340 that you're doing. I'm going to hand out graph paper. but I wanted to show you this website. There's a couple of them. This one is, it says there's spurious correlations website. They're kind of funny ones, like divorce in Maine and the per capita consumption of margarine. You would think that those would not be related to each other, right? And look at how closely their graphs are when they plotted that information, okay? Here's another one. The number of people who died becoming tangled in their bed sheets, and the total revenue generated from skiing facilities. And over the years, it was a pretty close match. So I put both these websites. The oil crude from Norway and the drivers killed in a collision with railway trains over the years. And so looking at that, there's a bunch of them. The other website I put on is this one that kind of talks about the definition of having causation versus correlation. What's the difference? So if you are really struggling with this, I would recommend you go to this, these two things and read through it just to get a little better. The biggest thing is, and they talk about this, is that a lot of people think that one statistic causes the other, and that's not always the case. This was another one that I found that you were looking at. Per capita cheese consumption and the number of people who died.
Why do they keep doing the bed sheets?
Divorce in Maine, that one came up a couple times. The revenue generated by arcades and computer science doctorates awarded in the United States. Again, you would think. So there's a bunch of them. Take a look through. It's kind of interesting. Your homework, as I said, is you're going to be doing this page.